Hi, in this video we're going to continue our discussion of the shortcuts for derivatives, and in this one we're going to talk about derivatives of exponential functions. So let's look at f of x equals e to the x. We want to find the derivative. So this is something new. The general power rule doesn't apply. Just to recap, the general power rule only applies when you have polynomials or x to a power. So if your function looks like y equals x to the n, then the derivative y prime is n x to the n minus 1. But in here, notice that x, the variable, is the base. For an exponential, right, e to the x is, our variable is the exponent. So those are two very different things. So here, our variable is in the exponent. For the general power rule, our variable x is the base. So this is an exponential function. So how do we find the derivative? Well, when we don't know what the derivative of something is, we're going to resort to the definition. So we're going to use the definition of the derivative. So we're going to use the limit as h goes to 0 of f of x plus h minus f of x all over h for f prime of x. So in our case, the derivative, so f prime of x is going to be the limit as h goes to 0 of f of x plus h. F of x is e to the x, so everywhere we see an x, we replace it with x plus h. So this will be e to the x plus h minus f of x. F of x is e to the x, so minus e to the x all over h. And so let's see, if I take the limit, if I plug in at h equals 0 now, I'm just going to get e to the x plus 0, so e to the x minus e to the x, so that's 0 over 0, which normally means do some algebra or something else. So here, let's split up. Let's reverse the rule of exponents that allow us to add exponents. So when are we allowed to add exponents? When we multiply the same bases, right? If I have e to the x times e to the h, when you multiply the same bases, you add the exponents. So that means I can then also go backwards. I can undo this rule by, if I have addition of exponents, that means it came from the same base being multiplied. So this will be e to the x times e to the h minus e to the x. And the reason that I'm doing this is because now I see that the e to the x term is common. So I can say this is the limit as h goes to 0 of e to the x times e to the h minus 1 over h. But now I'm still a little stuck because as h goes to 0, if I plug it in, e to the 0 will be 1. So 1 minus 1 is 0 over 0. So I still have 0 over 0, and I have no more algebra to do. So since this is the limit just as h goes to 0, the x is not being affected. So we can think of it as almost like a constant, right? H is the thing that's changing. So I'm going to say this is e to the x times the limit as h goes to 0 of e to the h minus 1 over h. And let's try a table of values to see as h goes to 0, what is this quantity doing? E to the h minus 1 over h. And so h close to 0 means we're going to plug in values like, say, 0.1, and then 0.01, and 0.00, let's write 3 zeros, 0.001. So try these on your calculator and see what kind of values are we getting. So press pause, try them on your calculator, and then we'll come together and see what we got. All right, so now that you have done it on your own, so when h is 0.1, I got 0.052, I believe, let me see, 0.052 5. If we round to 3 decimal places, I will round that 7 to 0.052. So 0.052, and then when h is 0.01, right, we're getting closer and closer to 0. So I wanted to share what I did in my calculator because I use parentheses. Your calculator, where if you don't have parentheses, it will automatically want to do order of operations. So if you did e to the 0.1 minus 1 without parentheses, divided that by 0.1, what your calculator will do is will do the division, 1 divided by 0.1, and then the subtraction. So your calculator is automatically programmed to do order of operations, so just be really careful. Make sure you use parentheses if you're trying to do the whole thing at once. So this is 1.005 if I'm rounding to 3 decimal places. Oops, I had a 0 in there, so it should be 1.005. And then when we do it for this 0.0001, let's go to our calculator. And so if you have one of these calculators or like a TI-30X2, it should still do the same thing. Right above the enter, you should see it says entry. And so if you go second and enter, it puts the previous entry there. And so you can just go back. And so what I'm going to do is I'm just going to insert. So second insert, and I'm going to add a 0. And then I'm going to go to the other one and do the same thing. So do second insert and add a 0. And actually we're adding 2 zeros, right? So add another 0. So now I have to go back to the other one and add another 0. So second insert, but then you get to see again what I do. And so that way I don't have to enter the whole thing all at once. So enter and I get 1.000. So rounding to 3 decimal places, right? This is 1.000. So, and if I go one more, what's going to happen? If I keep adding zeros, this is just going to get closer and closer to 1. So one of the things then that we can say is that the limit as h goes to 0 of e to the h minus 1 over h is going to get closer to 1. And so what we were doing here was finding the derivative of e to the x. So the derivative then of e to the x, once I find this limit is 1, I'm just going to get e to the x times 1, which is just e to the x. And so what we just found is that for f of x equal to e to the x, the derivative is also e to the x. So this is a nice little feature of our natural exponential function. The derivative is the same as the function itself. So what about something like, what was our next one that we had? So let f of x be, say, e to the 5x. Then what's the derivative of this? And I can do the exact same work, right? But instead of e to the x, I'm going to have e to the 5 times x plus h. So this will look like e to the 5x plus 5h, 5x, 5h, 5x. So everything will look the same, and then this limit is still going to go to, is it going to go to 1? I guess not. This is now going to go to 5. So this is going to be 5 times e to the 5x. So in general, what I can say is that for f of x equal to e to the kx, then what can I say about the derivative? The derivative is k times e to the kx. So it might look to you similar than the general power rule, but it's not, right? Because we get the exponential back and you just multiply by the constant in front of the x, so the coefficient in front of the x, rather than subtracting by 1 as we do with the general power rule. So let's try another example. This has everything now. So find dy dx for y equal to x to the 4th. So I'm using this notation. So this means find the derivative of y with respect to the variable x. This also tells you that y is a function of x. And so we're finding the derivative with respect to the independent variable, the x. So here, let's see, can I take the derivative? So I always inspect the function to see, can I take the derivative as it is, or do I need to rewrite anything? And right away I see that I have a 5 over x, so I need to rewrite that before I take the derivative. So then I'm going to rewrite it and say y is equal to x to the 4th minus 3x squared plus e to the 7x plus, how do I rewrite that? That will be 5 times x to the, is x to the first on the bottom, so it's going to be x to the minus 1 plus e. And so now let's see, where do I need to use the general power rule? So I have 1, 2, 3 terms that require the general power rule. And I have, how many exponentials do I have? I have an e to the 7x, so that's an exponential. Is this an exponential? Big question mark there. No, right? We don't have a variable as an exponent, so this is just a constant. So we can say, no, that's just a constant. It is the constant e. Remember, e is approximately 2.71828. So this is not an exponential, so I don't need the exponential rule. So now dy dx, which the other notation for dy dx is y prime, is, now I can start taking the derivative. So general power rule there, so 4x cubed, right, bring the power down and then decrease the exponent by 1. So what I'm doing, what I did here is 4 times x to the 4 minus 1. And then minus 3 times bring the power down, so 2x to the 2 minus 1. And so on. So that will be a minus, not a plus. So minus 6x to the first, 2 minus 1 is 1, plus the derivative of e to the 7x. Now e to the 7x, I can use this rule of exponentials. E to the kx is k times e to the kx. So my k is 7. So e to the 7x, the derivative then is what? Is 7 times e to the 7x. Right? My exponential doesn't change. I just multiply by that constant. And then this is a general power rule. So minus 5x to the minus 1 minus 1. You subtract 1 from the exponent plus the derivative of that e. E is just a constant, so the derivative is 0. So rewriting it, 4x cubed minus 6x plus 7 e to the 7x minus 5x to the minus 2. So that looks like our derivative, but we have a negative exponent, so we don't want that. So rewrite everything with a positive exponent. And so this will be minus 5 over x squared. Again, who does the negative belong to? Just to the x. If I had parentheses, 5x quantity to the minus 2, then I will move the 5 down as well. So be careful about those little mistakes. All right, so then that is our derivative for exponentials. And so you'll see them mixed in, general power rule, exponential, so you just have to decipher what's a polynomial, what requires a general power rule, and what requires the rule of exponential. All right, contact me if you have any questions.